Hello everyone, myself Vinay Kumar. So I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing about squares and square roots. So which is the 5th chapter in 8th standard mathematics subject. So here in 8th standard mathematics subject, the 6th chapter is cubes and cube roots. So if you want to understand cubes and cube roots properly, then you should understand squares and square roots properly. So if you want to understand squares and square roots, then please refer my previous videos where I have uploaded 4 parts on squares and square roots. So if you go through all the parts, if you go through all those videos, then it will be easy for you to grasp cubes and cube roots. So before moving into cubes and cube roots, there is an interesting story of Ramanujan. So when Professor Hardy went to meet Ramanujan, he actually told Ramanujan that he came in a car which has number 1729 as its registration number. So he told it's a dull number, 1729 is a dull number. So immediately Ramanujan replied to Hardy that 1729 is not a dull number, but 1729 is an interesting number which can be expressed as the sum of two cubes. Just like that, 1729 can be written as 1728 plus 1. So this 1728 is actually 12 cube and this 1 is actually 1 cube. That means 2 cubes. You are adding 2 cubes to get this 1729. That means this 1729 is not a dull number. It is actually the sum of two perfect cubes. So 1729 is a number which can be expressed as the sum of two perfect cubes. Not only 12 cube and 1 cube, 1729 can also be expressed as 10 cube plus 9 cube. Because 1729 can be written as 1000 plus 729. So 1000 is actually 10 cube, 729 is actually 9 cube. So two different perfect cubes you can add together to get 1729. That means in two different ways this particular 1729 can be expressed as a sum of two perfect cubes. Hence Ramanujan explained that 1729 is not a dull number, it's very interesting number. So that's why this particular 1729 is actually known as Hardy-Ramanujan number. So this 1729 is known as Hardy-Ramanujan number. So this is just a small introduction in this particular cubes and cube roots chapter. So let us understand what is cubes and cube roots. So if you refer my previous video, I have explained what is squares and square roots. Why the name square is existed. Because if you refer my quadrilaterals chapter, like if you refer the video where I have explained quadrilaterals, there I have explained a square is such a kind of quadrilateral which has all its sides equal and all its angles are equal. That means the length of the square and the breadth of the square is actually equal. That is L is equal to B. Hence, area of a square can be L square. So that's why this particular thing square has existed, because anything to the power of 2 is square. Similarly, the three-dimensional image of a square is cube. That means if I want to draw a cube on a two-dimensional place which has height as its third component. So in this particular cube, you have length, you have breadth. Similarly, you had length and breadth for square. Similarly, in cube also you have length and breadth, but here there is one more dimension, that is height. So that's why this particular cube is a three-dimensional image which has length, breadth and height. So to find the area of square, you used L square because length and breadth were equal. Area of a square is length into breadth. Since length and breadth are equal, L square was your area. So that's why anything to the power of 2 was known as square in general. So here also, to calculate the volume of a cube, you are actually multiplying length, breadth and height just to understand how much volume that cube have. like how much volume that cube is actually occupying in a space. So to understand that, we can actually calculate the volume of that particular cube. So volume of a cube or a cuboid will be length into breadth into height. Here, since length, breadth and height of a cube are same, just like in square, length and breadth are same, in cube, length, breadth, height, all three are same. All three are equal to each other. So I can easily write this as L into L into L, which is actually L cube. That means here anything to the power of 3 is referred to cube, because the volume of cube is represented as L power 3. That is length power 3, because length, breadth and height are equal. So the length power 3 is basically generally known as cube. So that's why here anything to the power of 3 we refer to it as cube. Anything to the power 2, that we actually refer to as square. So here L power 3 means L cube. That means that particular number or that particular value L has power 3. That means 3 times that particular L should be multiplied with itself. So this is actually the explanation for cubes. Similarly, when you refer my previous video, I have told the square root of a perfect square number is the root cause to get that particular perfect square number. So if you have 4 as your perfect square number, so 4 is a perfect square number means the square root of 4 is actually 2. That means when you actually multiply 2 times the 2, then you will actually get 4. That means 2 into 2 will be 4. So that's why to get the number 4, 2 times 2 should be multiplied with each other. So that's why 2 will act as the root of that particular square number. So that's why that particular 2 is known as square root. Similarly, here also for cube root, 3 numbers should be multiplied. Like the same number, 3 times it should be multiplied. Then you are actually getting a cube number. So that's why the root of that particular perfect cube or a cube is actually the cube root of that particular number. Let's say we have 8. So 8 is a cube, perfect cube. So the root of 8, the cube root of 8 is 2, 2, 2. Because when you do 2 into 2 into 2, you will actually get 8. Because 2 2s are 4, 4 2s are 8. That means to get 8, you are actually multiplying 2 3 times. That means 2 power 3. So this particular 2 has 3 in its power. Hence this becomes 2 cube. So 2 cube is actually equal to 8. So this particular 2 acts as cube root of this particular 8. So here 8 will become cube, and to get that cube, the number which you are using to get that particular perfect cube, so that particular number is actually the root of that particular perfect cube. So that's why that is known as cube root. So if 8 is a cube, then 2 becomes cube root of that particular 8. So one more thing which you should remember in this particular cubes and cube roots is that if you take cubes of an odd number, then you will get an odd number itself. If you take cube of an even number, then you will get even number. Just like if you take 1 and if you take power 3, like 1 power 3. So if you take 1 cube, then the answer will be 1. So cube root 1 is an odd number and its perfect cube is also an odd number. So now let us take an even number 2. So what is 2 cube? That is 8. So here you can see the cube root of this particular 8 is a even number. Hence 8 is also a even number. That means if a cube root is odd, then its perfect cube or its cube will be odd. So if a cube root is even, then its cube will be even. So here 1 is odd, hence 1 is odd. Here 2 is even, hence 8 is even. So this is one concept you should actually remember in this particular chapter. So here also some interesting patterns are actually given in this particular chapter. If you go on adding the consecutive odd numbers starting from 1, then you will go on getting perfect squares. This I actually discussed in the previous videos. Here, to get the perfect cube, you should go on adding the consecutive odd natural numbers, not starting from 1. So wherever you are ending the previous perfect cube, from there you should actually add the next consecutive odd natural numbers. So if you are getting confused, I will just explain by showing that. So 1 is an odd number, so this is a perfect cube. So 1 is perfect cube. After 1 you have 3, so you should take two numbers, that is 3 plus 5. So if you make 3 plus 5, you will get 8. So 8 is a perfect cube number. Here 1 is a perfect cube number. So because 8 is actually 2 cube. Similarly, if you take next 3 consecutive odd natural numbers after 5, that is 7 plus 9 plus 11. So if you add those 3 odd natural numbers after 5, 3 consecutive odd natural numbers, then you will get the third perfect cube starting from 1. That is, so 11 plus 9 is 20, 20 plus 7 is 27. That is actually 3 cube. So first you got 1 cube, next you got 2 cube, next you got 3 cube. Next, if you take 4 consecutive odd natural numbers after 11, that is 13, 15, 17, 19, and you add all these odd natural numbers, then you will actually get 64. 64 is actually 4 cube. Similarly, if you add 5 consecutive odd natural numbers after 19, then you will get the next perfect cube, that is for 5 cube. That is like 21 plus 23 plus 25 plus 27 plus 29 is actually 125. 125 is actually 5 cube. So like this pattern will be going on continuing. So this is one particular interesting pattern which you can actually observe in this particular chapter. Just like using prime factorization method, you find out square roots of a perfect square number in the previous chapter. So I have explained how to find out square root of a perfect square number using prime factorization method. And using prime factorization method, you can also identify whether a particular number is perfect square or not. Similarly, to find a particular number is perfect cube or not, and if that particular number is perfect cube, then what will be the cube root of that particular number? Here also you can use prime factorization method. So to find out cube root, there is a method called prime factorization, the same method which you actually used to find square roots in your previous chapter. So here also I will be discussing the same method to find cube roots. So prime factorization. So what is prime factorization method is that if a number is given to you and if you want to find cubes, like if you want to find cube roots of that particular number, then you should go on doing prime factorization with that number. You should take prime numbers and you should actually go on doing the prime factorization. So let me take 729. So 729 is a perfect square number, perfect cube number. So now I will do prime factorization of this particular 729. Let me see whether this 729 will go with 3 or not. So 3 2s are 6, 12, 12 will be there. So 3 4s are 12, 3 3s are 9. So again you can take 3. So here 3 4 8s are 24, 3 1s are 3. Again you can take 3, you will get 27. Again you can take 3, you will get 9. Again you can take 3, you will get 3. Again if you take 3, you will get 1. So that means here 6 times you should actually multiply 3 to get this particular 729. So 729 is actually equal to 3 into 3 into 3 into 3 into 3 into 3. So 6 times you should multiply 3. Using prime factorization, when you want to calculate the square root of a particular perfect square number, you are actually making group of two numbers which are same. So then you are actually calculating whether that particular number is perfect square or not. So in cubes, like if you want to find whether the given number is perfect cube or not, then you should actually make the group of 3 of same number and you should see whether all number are satisfied or not. So here 3, 3, 3. So all these 3 numbers are same. So I am making group of these 3 numbers together. And here also 3, 3, 3 is there. So I am making group of another 3 numbers which are same. So here you can clearly see there is no left out number. That means there is no independent number which is actually left alone. So here you can clearly see that all 3's are getting satisfied. So these 3's, like first 3 3's are grouping with each other and the next 3 3's are grouping with each other. So here take 1 3 from this particular set and take another 3 from this particular set. Just multiply these two 3's. So what is the answer when you multiply these two threes? You will get 9. That means cube root of 729 is 9. So cube root of 729 is 9. So this is the symbol for cube root. When you want to express a square root, then you will put this particular symbol. When you want to express cube root, then you should put this particular symbol and write 3 over here. So if you write 3 on this particular symbol, then this particular entire symbol will become cube root. So this symbol is actually square root. So if you put 3 on this particular square root symbol, then it will become cube root. So here also, using prime factorization, you can actually find whether a number is perfect cube or not, and you can also find the cube root of that particular perfect cube number. So based on this prime factorization method, you have certain examples in the textbook. You can refer those examples, and you have exercise 6.1. So I'll just solve exercise 6.1 now. So coming to the exercise 6.1, in that, in first question, they have given 5 different numbers. So as a 5 different questions, and they are actually asking which are the numbers which are not a perfect cube. So you should actually identify which numbers are not a perfect cube. So we should actually solve all the problems which are there in this particular question, that is first question, and we should actually note down which particular number is not the perfect cube. So coming to the first question you have 216. So if you do prime factorization of 216, you can take 2 as a prime number. So 2 ones are 0, 8. So again if you take 2, it will be 5, 4. So again if you take 2, it will be 2 2s are 4, 1 will be remaining 7. So if you take 3, then 3 9s are 27. So again this particular 9 can go with 3, and this particular 3 can go with 3. So you have 3 times 2 and 3 times 3. That means this particular 216 is actually equal to 2 into 2 into 2 into 3 into 3 into 3. So this particular 2 has group with it. Like all these 3 2's can be one group. All these 3's can be another group. So you can clearly see here there is no left alone number which is not included in the group. So this particular 2 has got grouped with each other. This particular 3 has got grouped with each other. Because 3 numbers should be there. Same numbers 3 times it should be there, and you can group that particular numbers. And then you should actually see whether there is a left alone number is there or not. So if it is there, then this particular number is not perfect cube. If it is not there, then this particular number is a perfect cube. So here, since there is no left alone number, this particular 216 is a perfect cube. So coming to the second question, they have given 128. So we should identify 128 is a perfect cube or not. So again we can do prime factorization using prime numbers. So if I take 2, it will be 64. So if I take again 2, it will be 32. So again if I take 2, it will be 2 ones are 2, 2 6 are 12. Again if I take 2, it will be 8. Again if I take 2, it will be 4. Again if I take 2, it will be 2, 2, 1. So here you can clearly see 2, 2, 2, 2, 2, 2, 2. So that means 7 times you should actually multiply to get 128. So 2 into 2 into 2 into 2 into 2 into 2. So here these 3 2's will get grouped with each other. These 3 2's will get grouped each other. So this particular 2 is left alone. So that's why 128 is not a perfect cube. So coming to the third question in this particular first question. So next if you solve 1000, you will get 10 as the cube root. Like if you go on solving this particular 1000 using prime factorization, then you will get 2. So this will go with 2. So you'll get 500. Again this can go with 2. It will get 250. Again this can go with 2. You'll get 125, 5, 25, 5, 5, 5, 1. So here you can clearly see 1000 can be expressed as 3 times 2 and 5 times 5. So that means here 5, 5, 5 are getting grouped each other. 2, 2, 2 are getting grouped each other. That means there is no left alone number here. So 1000 is actually a perfect cube. So coming to the fourth question in this particular first question, they have given 100. So 100 also you can actually do prime factorization for 100. So if you take 2, it will become 50. If you take 2, it will become 25. If you take 5, it will become 5. If you take 5, it will become 1. So that means 100 can be expressed as 2 into 2 into 5 into 5. So here you can clearly see this 5 and this 5 can group each other, but there is no one more 5 for this particular 5 to group, and there is no one more 2 to group this particular 2 into 2. Here you can see 2 and 2 can get group each other, and 5 and 5 can get group each other. That means 100 is a perfect square, but there is no another 2 and there is no another 5 to make it group of 3. So that's why 100 is not a perfect cube. 100 is a perfect square. So fourth one is also not a perfect cube. Coming to the fifth question in this particular first question, they have given 4, 6, 6, 5, 6. So again, when you follow prime factorization of this, you can actually go on solving this using all prime numbers, which is possible, and you can easily see there will be 3 numbers group of same numbers. So that actually concludes that this particular number is a perfect cube. Here 4, 6, 6, 5, 6 is also a perfect cube number. So in this first question, the second number, which is actually 128, is not a perfect cube, and the fourth number, which is actually 100, is not a perfect cube. So this is actually the answer for first question. So coming to the second question in this particular exercise, they have given 5 questions. I will solve 2 questions. So remaining 3 questions you can similarly solve. Coming to the first question in this particular second question, they have actually given 243 as number. So here in second question, you should actually find out the least number which should be multiplied with the particular number to get a perfect cube. That means these numbers which are given in this particular second question are not perfect cubes. So which number you should actually multiply for this particular number to get a perfect cube. So here also you follow the prime factorization and see which number is short to make group. So that number you should actually multiply to 243 so that you will get a perfect cube. The first question which is given here is 243. Let us follow prime factorization method. So 243, 3 can be used here. So 8 3s are 24. So 3 8s are 24, 3 1s are 3. Again you can use 3. So you'll get 27. Again you can use 3, you'll get 9. Again you can use 3, you'll get 3. So again you can use 3, you'll get 1. So here 243 can be expressed as 3 into 3 into 3 into 3 into 3 into 3. So 5 times you can actually multiply 3 to get 243. So here first 3 3's will get grouped with each other. So next 2 3's cannot group with each other because there is no one more 3 to group with these 2 3's. That means you should put one more 3 for this particular number so that this particular 2 3's can group with this 3 and you can get a perfect cube number. So that means this particular 243 should be multiplied with 3. So when you multiply 243 with 3, you will get a perfect cube number. So the answer here for the first question is 3. So 3 is the least number which you should actually multiply to that particular 243 to get a perfect cube number. So this is just the answer which is asked there. So you can leave it here itself. So whenever while writing and solving these particular questions, you should actually step by step explain what you are doing, and you should actually solve this particular question, and you should keep the answer in a statement form. Coming to the second question in this particular second question, or else I will solve the third question in this particular second question, that is actually 72. So let us do prime factorization of 72. So you can take 2. So 2 3s are 6, 12 will be there. So 2 6s are 12. So again you can use 2. It will be 2 1s are 2, 2 8s are 16. Again you can use 2, you'll get 9. Again you can use 3, 3, 3, 1. So 72 can be expressed as 2 into 2 into 2 into 3 into 3. That means here 2, 2, 2 can group each other. So for these 2 3's to group with each other, one more 3 is short. That means this particular number should be multiplied with 3. That means this should be multiplied with 3 so that these 2 3's can group with this particular 3. That means this 72 should be multiplied with 3. So when you multiply 72 with 3, you will get a perfect cube number. So here also the answer for third question is 3. So 3 is the minimum number which you should actually multiply to 72 to get a perfect cube number. So let me solve one more problem in this particular second question. So I will solve fifth question in this particular second question, that is 100. So if we do prime factorization of 100, we will get which number is short to make this particular 100 a perfect cube. So this particular 100 can go with 2, so you'll get 50. So again you can use 2, you'll get 25. You can use 5, you will get 5, 5, 1. So here you can clearly see 2 into 2 into 5 into 5 will give you 100. So here 2 and 2 cannot group with each other because one more 2 is short, and 5 and 5 cannot group with each other because one more 5 is short. That means this particular number should be multiplied with 1 2 and 1 5. So when you multiply this number with 2 and 5, then this particular 3 2's can get grouped with each other, and here these 2 5's can get grouped with this particular 5. That means 2 and 5 should be multiplied with this 100. That means this 100 should be multiplied with 2 and 5. So what is 2 into 5? 2 into 5 is 10. That means 100 should be multiplied with 10 to get a perfect cube number. So the answer for this fifth question is 10, because 10 is the minimum number which should be multiplied with 100 to get a perfect cube. Coming to the third question in this particular exercise, it is the reverse of second question. So in second question, you actually found out which is the minimum number you should actually multiply to that particular numbers to get a perfect cube. In this third question, you should actually find which number should be divided to get the perfect cube. So here clearly whichever number is left alone, you should actually divide that particular number from the number which is given so that you will get a perfect cube. So in second question you are multiplying. So in third question you will actually divide that particular number. So you should find that minimum number which you should actually divide to get a perfect cube number. So here the first question which is given in this particular third question is 81. So we can use prime factorization and solve this. So 81 can go with 3, so you'll get 27. So again 3, so you'll get 9. So 3 3s are 9, so you'll get 4 times 3. That means 81 can be expressed as 3 into 3 into 3 into 3. So this first 3 3's can group with each other, but this particular 3 is left alone. So you should actually divide by 3 so that you can get rid of this particular 3 and you can get a perfect cube. That means this particular 81 should be divided with 3. So when you actually divide 81 with 3, you will get a perfect cube number, that is actually 27, because 27 is actually 3 cube. So here the minimum number which you should actually divide to get a perfect cube is 3. So the same thing which you have done in the previous question, here you should actually remove the left alone number. So in previous question, to make it a perfect cube, you are actually multiplying the additional numbers which is required. So to remove one particular extra or two particular extra numbers which are there, so to remove that you will just divide by those numbers to with this particular number to get a perfect cube. So in 81, 3 was an extra number which was there, which didn't have any other 2 3's to make a group. So that's why we are actually dividing this particular 81 with 3 and we are getting a perfect cube, that is 27. So the answer for first question in this particular third question is actually 3. So coming to the fifth question in this particular third question, so remaining 3 questions you can actually solve like this, because if you solve second question, third question is just reverse of second question. So I will be solving just 2 questions in this particular third question. So answer for first question is 3. Coming to the fifth question in this particular third question, you have 704 as your number. So you can follow prime factorization and find out which number you should actually divide to get a perfect cube out of this 704. So this 704 can go with 2. So 2 3's are 6, 10, 2 5's are 10, next 2 2's are 4. Again this can go with 2. So 2 1's are 2, 2 7's are 14. So 1 will be remaining, 2 6's are 12. So again this can go with 2. 2 8's are 16, 2 8's are 16. Again this can go with 2, you'll get 44, 40. So again this can go with 2, you'll get 22. Again this can go with 2, you'll get 11. So again 11 will be remaining. So here you can clearly see 704 can be expressed as 2 into 2 into 2 into 2 into 2 into 2 into 11. So here these 3 2's can group with each other, these 3 2's can group with each other, but this 11 has no other 2 11's to group with. So that's why you should actually divide this with 11 so that you can actually get rid of this particular 11. So to get rid of that particular 11, you should actually divide 11 with this 704. So when you do 704 divided by 11, you will actually get a perfect cube. So 11 is the answer for this particular fifth question in third question. So when you actually divide 11 with 704, you'll get a perfect cube number. Coming to the fourth question in this particular exercise 6.1, they have given 5 centimeter into 5 centimeter into 2 centimeter. So here they have actually given a cuboid. Cuboid is a certain kind of three-dimensional image of a quadrilateral which has different length, breadth and height. That means all its length, breadth and height are not equal. If length, breadth and height of a particular cuboid is equal, then it will become a cube. So if it is not equal, then it will become a cuboid. So here 5 centimeter into 5 centimeter into 2 centimeter. That means here you can see one particular side is actually 2 centimeter and two particular sides of that particular cuboid is 5 centimeter. That means this particular cuboid is a cuboid, not a cube. So how many cuboids, this 5 centimeter into 5 centimeter into 2 centimeter cuboids, how many you require to get a perfect cube, so that the length, breadth and height of that final cube which you will get when you join all these cuboids together. So how many such cuboids you require to make that particular cube? So for example, if this particular cuboid has 5 centimeter into 5 centimeter into 2 centimeter like this. So let's say this particular cuboid is having this particular side as 5 centimeter, this particular side as 5 centimeter, and this particular height is actually 2 centimeters. So let us assume like this. So if you go on placing these cuboids with each other, you will form a big cube which is actually a perfect cube. So how many cuboids you should actually place on each other to get a perfect cube? So to get a cube shaped object. So to find that, you should actually find what is the volume of this particular cuboid. So to find volume of this particular cuboid, you should actually multiply 5 centimeter into 5 centimeter into 2 centimeter. What will be the volume of this? So 5 5 is 25, 25 into 2 will be 50. So 50 centimeter cube is the volume of this particular cuboid. So using this 50, if you actually do the prime factorization, you should actually identify which more numbers you should actually multiply to make this 50 a perfect cube. Because 50 is not a perfect cube. Because 5 centimeter, 5 centimeter and 2 centimeter length, breadth and height of this particular cuboid is not equal. Hence 50 is not a perfect cube number. So you can do prime factorization and find how many more things, or like how many more number you should actually add to make this 50 a perfect cube number. So that many numbers which you will add for this 50 to make this 50 a perfect cube number will be the number of cuboids which is required to make a perfect cube out of this cuboids. So let us use prime factorization. So this can go with 2. So when you use 2, you'll get 25. When you use 5, you'll get 5, 5, 1. So this 50 centimeter cube can be expressed as 2 into 5 into 5. So here 5 and 5 cannot group with each other because there is no one more 5 which is required. And this 2 also cannot group with any others because 2 doesn't have another 2 2's, so that this particular 2 can group with them. So that means this particular 2 is short with 2's and this particular 5 is short with one more 5. That means you should multiply this particular number with 2 times 2 and 1 time 5. So when you multiply 2 times 2 and 1 time 5, then this 2 5's will get 1 5 and these 2 will get another 2 2's to get grouped with each other. That means you will get a perfect cube number. So if you multiply 2 into 5, so you will actually get 20 because 2 2's are 4, 4 5's are 20. So when you multiply 20 with 50, you will get 1000. So when you multiply 50 with 2 into 5, that is actually 50 into 2 2's are 4, 4 5's are 20. So when you multiply 50 with 20, you will get 1000. That means 20 cuboids are actually required to make a perfect cube out of those cuboids. So that means the answer for this question is 20 cuboids. So 20 cuboids are actually required to make a perfect cube out of those cuboids of length, breadth and height equal to 5 centimeter into 5 centimeter into 2 centimeter. So coming to the next exercise, that is actually exercise 6.2. So now I have explained you what is cubes and I have also explained you what is cube roots. and I have also explained how to find a particular number is a perfect cube or not, and how to find cube root of that particular perfect cube. So to find that cube root of a particular perfect cube, you should actually use prime factorization method. So now coming to exercise 6.2, you have two questions in this particular exercise 6.2. So let us go on solving those two. So coming to the first question in this particular exercise 6.2, they have given like 10 questions. So in this all 10 questions, you have perfect cubes, and you should actually find the cube roots of these particular 10 questions. So in that I'll solve 3 questions. So remaining 7 questions you can actually solve, because I have taught you how to do prime factorization and find the cube root of a particular perfect cube number. So the first question in this particular first question is 64. You can do prime factorization and find the cube root of 64. So you can use 2 here. So this can go with 2. 2 3s are 6, 2 2s are 4. Again this can go with 2, you'll get 16. Again this can go with 2, you'll get 8. Again this can go with 2, you'll get 4. Again this can go with 2, 2, 1. So you got 6 times 2. That means 64 can be expressed as 6 times multiplication of 2. So 2 into 2, 2 into 2, 2 into 2. So these 3 2's can group with each other, and these 3 2's can group with each other. There is no left alone number. That means 64 is a perfect cube. Take 1 2 from this particular group and take another 2 from this particular group and multiply these two 2's. So what is 2 into 2? 2 into 2 is 4. That means cube root of 64. So this is the symbol for cube root. So you should put the symbol for square root and put 3 on this particular symbol. Then this particular symbol will become cube root. So cube root of 64 is actually equal to 4. So coming to the fifth question in this particular first question, you have 15625 as your number. So you can actually use prime factorization method. So 15625 can go with 5. So 5 3s are 15, 5 1s are 5. So again 1 will be remaining, 5 2s are 10. So 2 will be remaining, 25, 5 5s are 25. So again this 3125 can go with 5. So 5 6s are 30, and again 1 will be remaining. So 5 2s are 10, 2 will be remaining, 25, 5 5s are 25. So again this can go with 5, you will get 125. Again this can go with 5, you will get 25. Again this can go with 5, you will get 5 5 1. So that means this 15625 can be expressed as 6 times multiplication of 5. So that is 5 into 5, 5 into 5, 5 into 5, 5 into 5. So here these 3 5's can group with each other, these 3 5's can group with each other. Take one 5 from this particular group, take another 5 from this particular group and multiply them together. So 5 into 5 will be 25. So the cube root of 15625 is actually 25. So coming to the ninth question in this particular first question, they have actually given 175616. You can use prime factorization method and go on solving this particular number. So let us use 2 here. 2 8s are 16, 15 will be there, 2 7s are 14, 1 will be there, so 16, 2 8s are 16. So again 1 is there, so this particular 16 is there, so 0. So 16 means 2 8s are 16. So again this can go with 2, so 2 4s are 8. Again here 7 is there, so 2 3s are 6, 1 will be remaining, so 18. 2 9s are 18, so 0 is there, 2 4s are 8. So again you got 43904. Again this can go with 2. You will actually get 2 2s are 4, 2 1s are 2, 2 9s are 18, 1 will be there, 2 5s are 10. So again 4 is there, 2 2s are 4. Again this can go with 2. So this can again go with 7. So 7 4s are 28, 6 will be remaining, 63. So 7 9s are 63. So again this can go with 7, you will get 7. Again this can go with 7, you will get 1. So here you can see 1 2 3 4 5 6 7 8 9. 9 times 2 you have multiplied and 3 times 7 you have multiplied. That means 1755616 can be expressed as 2 into 2 into 2 into 2 into 2 into 2. So how many times? 9 times you should actually multiply with 2. So here it is 6 times, so 2 into 2 into 2. So again this should be multiplied with 7 into 7 into 7. So here these 3 2's can group with each other, these 3 2's can group with each other, these 3 2's can group with each other. So here these 3 7's can group with each other. take 1 2 from here, 1 2 from here, 1 2 from here, and 1 7 from here. So it will be 2 into 2 into 2 into 7. So 2 2s are 4, 4 2s are 8. So it will become 8 into 7. So 8 7s are 56. So the cube root of 1756. So this is symbol of cube root. So cube root of 175616 is actually equal to 56. So coming to the second question in this particular exercise, you have true or false in this particular question. So there are 7 different statements given, and you should actually state whether those statements are true or false. So coming to the first question in this particular second question, they have actually given cube of any odd number is even. No, it is actually false, because if you refer in the first property where I have discussed, cube of a odd number will be a odd number. Cube of an even number will be an even number. But here they are giving cube of any odd number will be even. So that is actually false. So false is the answer for first question. So coming to the second question in this particular second question, they have given perfect cubes will never end with 2 zeros. That is actually true, because always you should remember perfect cubes will end with 3 zeros or with the multiple of 3 zeros, like 6 zeros, 9 zeros, 12 zeros, like this. It will never end with 2 zeros or 4 zeros or 5 zeros, like that. So here also they have given 2 zeros, like perfect cube will not end with 2 zeros. That is actually true. So the answer for second question is true. So coming to the third question in this particular second question, they have given if square of a number ends with 5, then its cube ends with 25. That is actually not always true, because sometimes it may end with 25 or sometimes it may not end with 25. So the answer for third question is false. Coming to the fourth question, here they have given there is no perfect cube which ends with 8. No, 8 itself is a perfect cube. So this particular perfect cube is actually ending with 8, because 8 itself is a perfect cube. That means this particular fourth question is false. That means perfect cubes can end with 8 as well. So there are some perfect cubes which can end with 8 as well. So the answer for fourth question is false. So coming to the fifth question in this particular second question, they have given the cube of a 2-digit number may be a 3-digit number. No, actually cube of any 2-digit number is actually more than 3-digit number. So let us take the least 2-digit number. So the least 2-digit whole number is 10. So what is 10 cube? 1000. Here you can clearly see there is 4 digits. So the least 2-digit number itself have 4 digits in its perfect cube, means no 2-digit number will have 3 digits in its perfect cube. But they are actually given here that cube of a 2-digit number will be having 3 digits. So that is actually not true. So the answer for fifth question is also false. Coming to the sixth question in this particular second question, they have given the cube of a 2-digit number may have 7 or more digits. So here they are giving cube like perfect cube of a particular 2-digit number will be having 7 digits or more than 7 digits. So let us actually take the maximum 2-digit whole number, that is actually 99. So when you make 99 into 99 into 99, that is when you actually take the cube of 99, let's see what will be the number. So 99 into 99 into 99 will be 9,70,299. So the answer for 99 into 99 into 99 is 9,70,299. That means here you can clearly see the cube of a particular number 99 has 6 digits in it. So 99 is the maximum 2-digit number. So the maximum 2-digit number itself have 6 digits in it. Like when you take cube of that particular maximum 2-digit number, you are getting 6 numbers in that particular cube. That means here they are given any, like if you take some 2-digit number, you can have cube which is actually having 7 digits or more than 7 digits. Here we can clearly see the maximum 2-digit number, when you take cube of it, it is not crossing 6 digits. So it is actually getting stopped at 6 digits itself. That means this particular sixth question is false. Like the statement which is given in this particular sixth question is false. So coming to the seventh question in this particular second question, they have given the cube of a single digit number may be a single digit number. So it is true because cube of 1 is actually 1. Cube of 2 is actually 8. That means these two examples are more than enough that particular single digit number can have single digits as its cube also. So because 1 is a cube root, so cube of that 1 is also 1. That means 1 is a one digit number. So 2 cube is 8. 8 is also single digit number. That means there are two cases here, that is 1 cube and 2 cube, which can give you perfect cube, which is actually single digit numbers. So here also they are saying there may be a single digit number which may have single digits as its cube. So two cases are there. Hence seventh question, the answer is true. So in this particular second question, only second and seventh statement are true. Remaining all other statements are false. So this is all there in this particular exercise 6.2. So and this is all there in this particular video as well. So if you like my video, if you enjoy my video, and if you want to learn more physics, chemistry and mathematics in my YouTube channel, then please do subscribe to my YouTube channel and stay tuned with my YouTube channel, because in my channel I will be uploading physics, chemistry and mathematics starting from 8th standard till 12th standard. So please subscribe to my channel and stay tuned with my channel. Thank you.